Good afternoon, guys. Welcome to the 27th lecture of refrigeration and air conditioning subject. Today, we discuss about the topics of evaporators. In this class, we'll discuss about what are the various types of evaporators, their working principle, their construction and mechanism. Right? So, coming to the types of evaporators, in the last class we have discussed the various types of classification of evaporators and the working principle of a basic evaporator, right? So today in this class we'll discuss the various types of evaporators which are used for vapor compression refrigeration system as well as absorption compression refrigeration system. Okay, now we'll start. The first type of evaporator is the shell and coil evaporators. So what are the shell and coil evaporators? The name given, shell and coil. The shell and coil evaporators shown in the figure 11.8 are generally dry expansion evaporators. Okay, so the name shell and coil evaporators or the dry expansion evaporators to chill the water. So in order to cool the water, so this type of shell and coil evaporators are generally used. The cooling coil is a continuous tube. The cooling coil, whatever is placed inside the evaporator, is a continuous tube, continuous cooling tube that can be in the form of a single coil evaporators used for drinking water. See here, this is a cooling coil where the liquid is passed inside this coil and it is surrounded in a spiral form and the suction outlet is in this manner, right? So here we are dumping the water. So this is a shell, tank shell. Here the water is in, here the water is out, right? So the cooling coil is a continuous tube that can be in the form of a single or a double spiral. So this can be of a single spiral or it can be of a double spiral. See here, this is a double spiral type shell and coil evaporator. This is also shell and coil evaporator. The shell may be sealed or open. So you can seal in the see this one. This one is a shell which is sealed like this. So this shell can be opened or it can be sealed. The sealed shells are usually found in the shell and coil evaporators used to cool the drinking water. The evaporators having flanged shells are often used to chill the water in secondary refrigeration system. So these are having a flange type of setup where these are used for cooling the water as well as drinking the water. Another type of shell and coil evaporator shown in the 11.9. Both types of evaporators are used where small capacity, that is 2 ton to 10 ton liquid cooling is required. It may be noted that the shell and coil evaporator is restricted to operation above 5 degrees centigrade in order to prevent the freezing problems, right? So the basic temperature of this coil evaporator is 5 degrees centigrade in order to what? In order to prevent the freezing problems. In order to prevent the freezing problems. The shell and coil evaporator, here we are having the liquid inlet and the liquid outlet. So inside the shell, the water is drawn, right? So here the water is outlet. Here the cooling coil. These are the cooling coils which are wounded, single wounded or double wounded. So it is a thick cylinder shell closed with a flanged closing. Here the liquid is going inside, the liquid is sucking outside. The same setup if you see here, the horizontal setup where the water is flowing here, the water drain is coming outside. Here the coil are double shaped, other design where you are shown in the U shaped. Later this one is connected to the liquid connection and this is liquid suction connection. This is the floor mounted horizontal type of tank. This is a vertical tank which is a small and portable when compared to this shell and coil evaporator. Next. The next type of evaporator is bare tube coil evaporator. The name says bare means without any enclosed casing. Bare tube coil evaporator. The simplest type of evaporator is a bare tube coil evaporator shown in the figure 11.14. Here the bare tube coil evaporators are also known as the bare tube coil evaporators are also known as prime surface evaporators. The name of the bare tube coil evaporators are prime surface evaporators, right? Because of why they are saying as a prime surface, because of the simple construction. The bare tube coil is easy to clean and defrost. Defrost అంటే చెప్పాను కదా, ఫ్రిడ్జ్ ని మనం ఎట్లా మనము వాటర్ గడ్డగట్టిన తర్వాత లోపల డిఫ్రాస్ట్ చేస్తే ఎట్లయితే కరిగి బయటకు వస్తుంది వాటర్ రూపంగా, ఇట్ ఈస్ వెరీ ఈజీ టు క్లీన్ అండ్ defrost. See here you are having a liquid refrigerant where it is sent inside. We are having expansion valve, right? Here the suction line is going to the compressor point. A little consideration will show that this type of evaporator offers relatively little surface contact area as compared to the other types of coil. The amount of surface area may be increased when by simply extending the tube. The surface area can be increased, depends upon the length of the tube, but there are disadvantages of excessive tube length. The effective length of the tube is limited by the capacity of expansion. The effective length of the tube is limited. The effective length of the tube is limited by the capacity of expansion valve. If the tube is too long for a valve's capacity, the liquid refrigerant will tend to be completely vaporized early in its progress through the tube. So, the excessive superheating at the outlet, the long tubes will also cause considerably greater pressure drop between the inlet and outlet of the evaporator. This reduces suction line pressure. So that's why the bare tube coil evaporator is the simplest form which can be used for the basic purpose, and it is very easy to clean and defrost. Okay, the length and the surface area depends upon what? The contact area, and the effective length of the tube is limited by the expansion valve. So the expansion valve యొక్క specifications, based upon the specifications, the length of the tube is adjusted, right? The next third one is the the finned evaporators. The name itself saying finned, so we are having fins on the evaporator. The finned evaporators. The fin evaporators shown in the figure, this one, consist of a bare tubes or coils over which the metal plates or fins are fastened. Okay, the finned evaporator consists of a bare tubes. So see the bare tube, just like a bare tube evaporator, it is having the bare tube. Just it is a development of the bare tube evaporator, right? So this one is a simple extension or a development in the bare tube evaporator is finned evaporators. Okay, the finned evaporator shown in the figure consists of bare coils as shown in the bare tube. Only the metal plates or fins are arranged and fastened in this form as shown in the figure. The metal fins are constructed on thin sheets. The metal fins are constructed on the thin sheets. One second. The metal fins are constructed on the thin sheets having a good thermal conductivity. The shape, size and spacing of the fins can be adapted to provide a best rate of heat transfer for a given application. So in order to have a good rate of heat transfer, the fins can be arranged according to the shape, size, and spacing. So the fins generally increase the contact surface of the heat transfer. The fins greatly increase the contact surface of the heat transfer. Therefore, the finned evaporators are also called as extended surface evaporators. Got it? Since the fins greatly increases the contact surfaces of the heat transfer, therefore the finned evaporators are also called as a extended surface evaporators. So ఇందాక మనం చెప్పుకున్నట్టు the bare surface evaporator is the advanced form is a finned evaporators. See here, just like your bare type, we don't have expansion valve, just the liquid refrigerant is passing here. The liquid refrigerant is passing here, and this is entering into this coil and entering into the evaporator. So these are the fins which are arranged and phased like this. So if you see the plate type, so just a place is phased in place of finned, and the arrangement is as usual like a finned evaporator. Next one. The finned evaporators are primarily designed for the air conditioning applications where the refrigerator temperature is about 0 degrees centigrade. So this type of finned evaporators are generally designed where the temperature is above 0 degrees centigrade. So it is not considering the minus degree centigrade. Because of the rapid heat transfer of the finned evaporator, because of the rapid heat transfer of the finned evaporator, it will defrost itself on the cycle of the off cycle when the temperature of the coil is near 0 degree centigrade. Right? A finned coil should never be allowed to frost because the accumulation of frost between the fins reduces the capacity. So here the space is reduced when it is frosted. That's why it's not never allowed to be frost because of accumulation of the fins reduces the capacity. So the air conditioning coils, the air conditioning coils, the air conditioning coils will operate at suction temperatures which are high enough so that frosting never occurs, having fin spacing as small as 3 mm. The finned coils which frost on the cycle and defrost on the off cycle have wider spin spacing. So it depends upon the applications and depends upon the specification of the usage. The finned evaporators can be altered as per the specifications and applications. అర్థమైందా? Next. The next type is shell and tube evaporators. The next type of evaporator is a fourth type is a shell and tube evaporators. So see the figure here. This the pink color portion is a vertical, is a horizontal cylindrical type shell, right? Cylindrical type shell where it is a thick form of shell. So here the liquid is entered into the shell and the chilled liquid water is going outside. So inside the cylindrical shell, a design. So what is a design? So a design is made for this evaporator. Here we are having by the name, this is a shell. Inside this we are having a tubes. So shell and tube evaporator. So the blue color portion, everything is a tubes which are designed in that form. Here the liquid refrigerant is passing at one section and the vapor refrigerant to the compressor. The vapor is sending vapor refrigerant to the compressor on the other side. So this is a thermostatic expansion valve where it can be used for controlling the process. So these are the baffles or spaces which are provided inside the shell, right? So the shell and tube evaporator is similar to the shell and tube condenser. So condensers ఇంకా మనం డిస్కస్ చేయలేదు. So here they are saying that the shell and tube evaporator is similar to that of the shell and tube condenser. It consists of a number of horizontal tubes enclosed in a cylindrical shell. It consists of a number of horizontal tubes enclosed in a cylindrical shell. The inlet and outlet headers, the inlet and outlet headers with perforated metal tube sheets are connected at each end of the tube. Okay, the inlet and outlet headers, with perforated metal tube sheets are connected to each other at the end of the tube. Okay, these evaporators are generally used to chill the water or brine solution. So this type of shell and tube evaporators are generally used for chilling the water or the brine solution. When it is operated, as a dry expansion evaporator, the refrigerant circulates through the tubes and the liquid to be cooled, which fills the space around the tubes within the shell. The dry expansion shell and the tube evaporators are used for refrigerating units of 2 to 250 TR capacity. When it is operated as the flooded evaporator, the water or brine flows through the tubes. Okay, the whatever the figure shown, the water or brine flows through the tubes and the refrigerant circulates around the tubes. The brine, right? The brine circulates around the tubes and the water is inside the tube. The flooded shell and tube evaporators are used to refrigerating units of 10 to 5000 tons capacity. That is about the shell and tube operators. Next one, defrosting evaporators. Defrosting evaporators. A defrosting evaporator is one in which frost accumulates on the coils. Okay, so this type of evaporator is one where the frost will accumulate on the coils when the compressor is running and melts after the compressor shut off. So whenever the compressor is in on condition, so whenever it is running in condition and melts once the compressor shut off, then the frost will accumulate on the coil. During the running of the compressor, the evaporator remains at the temperature. Okay, during the running of the compressor, what happens, the evaporator remains at constant temperature at some temperature about -7 to 6 degrees centigrade. At these temperatures, what happens, the frost forms on the coil surface. So ఎప్పుడు frost ready అవుతుంది, so whenever the temperature is about 6 degree -6 degrees to -7 degrees, at that point of time the frost will be on the coil surface. But after the compressor stops, so once the compressor stops, the coil will become heat. Once it is warm up, automatically the temperature above 0 degrees centigrade and the frost melts before the compressor. So that happens in the defrosting evaporator section, right? Defrosting evaporator section. Okay, next. Uh, a defrosting evaporator is usually a finned coil type of evaporator because of the necessity of rapid heat transfer during the off cycle. So in order to dissipate the heat, in order to transfer the heat during the off cycle, the defrosting evaporator is generally used, and it has a finned type of coils. It also keeps a high relative humidity of about 90 to 95%. However, the sacrifices of each temperature difference between the evaporator refrigerant and the air in a cabinet. It requires greater evaporator area to make up this loss, right? Sometimes the defrosting evaporator presents a problem. What is that? In small installations, the top of the evaporator may defrost and the moisture flows down the evaporator surface. So this will be a problem. The moisture may not have sufficient time to escape before the compressor lowers the temperature of the evaporator to -7 degrees centigrade to -6 degrees centigrade. When this happens, When this happens, the ice accumulates at the lower part of the evaporator, and this ice accumulation of the evaporator fins maybe the maybe my maybe the free circulation of air around the coils. Okay, free circulation of the free circulation. The fins may be block the free circulation of air around the coils, thereby reducing the effectiveness of the evaporator. Reducing the effectiveness of the evaporator. That is about the defrost evaporators. Next one. What are the various methods of defrosting the evaporator? So defrost ఎలా జరుగుతుందో మనము తెలుసుకున్నాం. నెక్స్ట్, వాట్ ఆర్ ద వేరియస్ మెథడ్స్ ఆఫ్ defrost the evaporator? సో defrost చేయడానికి ఎన్ని రకాలైన మెథడ్స్ ఉన్నాయి? We will discuss, not in detail, just only the types, the methods of defrost evaporator. See here, when the air is cooled below its dew point temperature, it gives up the moisture and deposits on the nearest colder surface. Okay, so it gives up moisture and deposits on the nearest colder surface. Since the colder surface in the refrigerated area is a evaporator, therefore the moisture deposits on the surface of the evaporator. So when the temperature of the evaporator falls below 0 degrees centigrade, okay, and the temperature of the evaporator falls below 0 degrees centigrade, the moisture deposits on the surface of the evaporator freeze. Okay, the moisture deposits on the surface of the evaporator freezes and forms the coating of frost. If this frost is not removed periodically, around the coils of reducing the effectiveness of the evaporator. Okay, the various methods because of the colder surface in the refrigerated area is the evaporator. When the temperature of the evaporator falls below 0 degrees centigrade, the moisture deposits on the surface of the evaporator freezes and forms a coating of a frost. If this frost is not removed periodically, it acts as an insulator. So if it is not possible to remove, so if this frost is not removed periodically, so మనకి frost అనేది every weekly or 5 days or months, once in a month, so if you are not removed properly or periodically, it forms as an insulator and retards the heat transfer rate retards the heat transfer rate between the air and the evaporator, which causes the compressor to run at lower suction pressure. So when the compressor is running at lower suction pressure because of the frost acts as a insulator, then what happens? The load will become more. Under such conditions, the capacity and efficiency of see here the manual defrost process. So this is a pen, there's a pen, the water drips into the removable pan. So whatever the defrost happened on this place, once it is switched off, the water droplets will drips onto the removable pan. So that is a manual defrost method. And the insulator retards the heat transfer rate between the air and the evaporator, which causes a compressor to run at the low suction pressure. Okay, under such conditions, the capacity and efficiency of defrosting system decreases. So, when an evaporator operates below 0 degrees centigrade, it must be defrosted periodically for the efficient. So here what happens here? The evaporator operates below degree centigrade. So it may be defrosted periodically for the effective efficient operation of the system. The various methods that are used for defrosting the evaporators are: first method is manual defrosting method. Second one, pressure control defrosting method. Third one, temperature control defrosting method. Fourth one, water defrosting method. Fifth one, reverse cycle defrosting method. Next one, simple hot gas defrosting method. Next one, automatic hot gas defrosting method. Next one, the next one is uh, automatic hot gas defrosting method. Eighth one is thermo bank defrosting method, and the last one is electric defrosting methods. So these are the various types of defrosting methods where in the uniform defrosting methods where the so these are the various types of defrosting methods which you are not using any type of business in your profession, right? Now we'll see one of the case, that is electric defrosting method, how the electric defrosting method has been done. So see here the electric heaters embedded in fins for defrosting. So electric heaters embedded like fins and for used for defrosting process. The electric defrosting method is properly used for low temperature evaporators. So these are generally used for low temperature evaporators. In this system, the heating coils for heavy in the system, the heating coils for heating may be installed within the evaporator, around the evaporator, or within the refrigerant passes. So what happens in this system, the heating coils for heating can be placed at any point at the evaporator or around the evaporator or at within the refrigerant passes. Special evaporators are required for installing this type of system. Special evaporators are required for installing this type of system. In one of the electric defrosting methods, the electric heater is mounted under the evaporator, drinking its right. Electric heater is mounted on the evaporator where the drain pan and the drain line is also placed. Now, during the operation, the compressor is stopped and the liquid line is closed. The refrigerant from the evaporator is pumped into the downwards, and the electric heaters are then turned into the melt the frost from the surface of the evaporator and to the heat of the drain pan and the line to prevent the refreezing. After the defrost cycle, when the ice plant is frosted or removed, what happens? A thermostatic control returns the refrigeration system to the normal position. Okay, so that is about the electric discharge method. Next, the next category of this third unit is the second topic is condensers, right? So condenser. So what is the name the condenser has been given? Condenser is also an important device for the refrigeration system, and not only for refrigeration system. These are used for other applications in the electrical wiring, right? The condenser is an important device used in high pressure system. Okay, the condenser is a device which is okay. The condenser is an important device which is used in high pressure side of refrigeration system. The function is to remove the heat and the hot vapor refrigerant discharged from the compressor. Compressor నుంచి వచ్చిన hot air, the compressor నుంచి వచ్చిన the high pressure, the hot air to remove the heat of the hot vapor coming from the compressor. The hot vapor refrigerant consists of heat absorbed by the evaporator and the heat of compression added by the mechanical energy. So how the mechanical energy is by the motor. The heat, the heat from the hot vapor refrigerant, the heat from the hot vapor refrigerant in a condenser is removed by the first by transferring it to the walls of the condenser. So how the heat is removed? The heat is removed layer by layer. First it is removed first by the transferring it to the wall of the condenser, and then from condenser to other condenser, and from it to the outside layer to the walls of the condenser tubes, and then from the tubes to the conducting or cooling medium. The cooling medium may be the air or water or a combination of both. That happens in the condensers whenever they are purchasing. Next, if you see the figure, so that is a simple type of condenser where it is attached to the table and which are used for cooling the medium. Okay, the selection of a proper condenser depends on the what capacity of a refrigeration system. The selection of condenser depends upon the capacity of the refrigeration system. The type of refrigeration used and the type of cooling system medium is available. Okay, now we'll see how the working of a condenser will do. How the working of a condenser will operate in the refrigeration system, which can be used for both compression VCR vapor compression system and absorption compression system. Okay, right. Take down. The working of a condenser may be the best understood by what considering a simple refrigeration system. So by taking a simple type of refrigeration system, right? The com the corresponding pH diagram, the corresponding pH diagram. Now see here, the figure 10.1 shows the corresponding pH diagram, shows the three stages of the refrigerant cooling, and figure 10.1b shows the compressor draws with the superheated vapor, contains the heat it absorbed in the evaporator. The compressor adds more heat. The compressor ఏం చేస్తుంది? It adds more heat to the superheated vapor. The compressor will add more heat to the superheated vapor. This highly superheated vapor from the compressor is pumped to the condenser. ఏం జరుగుతుంది? The highly superheated vapor from the compressor, it will be pumped to the condenser through the discharge line. The condenser cools the refrigerant in the following three stages. So how the condenser will be cooled in the refrigerant? So the condenser cools the refrigerant. So if you get any question, what are the various ways of cooling the condenser? So first you have to write the definition of the condenser and the usage of a condenser and how the compressor is arranged in the setup refrigerant in the three stages. So what is the first stage here? The first stage is the superheated vapor is cooled to the saturation temperature corresponding to the pressure of the refrigerant. The superheated vapor is cooled to saturation temperature pressure to the refrigerant, right? So this is shown on the line 2-3 in the figure. The desuperheating occurs in the discharge line in the first few coils of the condenser. So how it is done, see here, see here the line. So this is the enthalpy, the y-axis is the pressure. So the 1 to 2 is a compression process, 2 to 3 is a, see here, the 1 to 2 is a compression zone, from 2 to 3 is a de-superheating, and 3 to 4 is a condensation, and 4 to 5 is a subcooling, and 5 to 6 is the expansion process. So these are the pressure and enthalpy system that is shown on the graph. Now if you see the schematic diagram of simple refrigerating system, so where the condenser is located, See here, the suction line, the evaporator place, and this is a reservoir, this is the expansion valve. When the when the electrical system is, see here, the electrical system is on the one side, right? So it is attached to the regulator, and here the lightweight refrigerant is passed. The light refrigerant is passed inside the coils and the condenser. So superheated vapor refrigerant will be formed at the other layer of this simple refrigeration system. Got it? The temperature, next, second point. Now the saturated vapor refrigerant gives up the latent heat and is condensed to the saturated liquid refrigerant. This process is known as condensation process. So the figure 3.4. So what we have discussed in the earlier classes, it is the condensation process, right? It is a condensation process where the few coils are the removed. Now the temperature of the liquid, the temperature of a liquid refrigerant is reduced below the saturation temperature. Then in order to increase what? The refrigeration effect. The temperature of the liquid refrigerant is reduced below the saturation temperature in order to increase a refrigeration effect. This process is shown in the figure 4.5. See the figure 4.5. 4.5 is a subcooling place where the total heat is rejecting slowly. Right? Next. See. So here the phase is shown 1 to 2 for the compressor. 1 to 2 is a compression. 1 to 2 is a compression. Next 2 to 3, 2 to 3 is next. So here the 1 to 2 and 2 to 3 discharge line, and 3 to 4 is a condenser process. Next 4 to 5, and 4 to 5 is a what? 4 to 5 is subcooling process, and 5 to 6 is a expansion process. So there is a process happening in this condenser stage. Got it? So the working of a condenser can be done by the three stages, right? And the condenser is also an important device used in the high pressure of a refrigeration system. But next, so this is an important figure for the simple setting of the refrigeration system, right? In the tomorrow's class, we'll discuss about the factors affecting the condenser capacity and the classification of condensers, and we'll discuss each thing in detail, right? So we'll stop the class here. So in this class, we have discussed about the types of evaporator in detail, the fin evaporators, the flanger evaporators, the drum and the shell and tube evaporators, the finned evaporators, etc. And the next thing is introduction to the condensers, why the need of condenser is be used, and what are the classification of condensers, and what are the working principle of a condenser. So in the tomorrow's class, we'll discuss what are the factors affecting the condenser and the classification of the condenser in detail. We'll stop the class here.